Okay, so this is 3.5 and it's writing an equation in slope-intercept form. So let's say you have an equation like 2x plus 3y equal to 12. And we want to solve this for the slope-intercept form. This really means solving it for y. You should solve it for y. And notice that's what it'll give us, because slope-intercept form is y equal to mx plus b. And so if we solve this for y, we're getting the same thing, the slope-intercept form. So we're going to start off by subtracting 2x, because this is plus 2x to both sides. Okay, and then we'll get 3y equal to negative 2x plus 12. Now we're going to divide by 3 on everything. So 3 divided by 3 is 1y, or y. This is going to be negative 2/3 x. And 12 divided by 3 is 4. So we can easily do that now. And we can graph it now too. So we can go down here and we can graph the y-intercept. And the y-intercept is 4. So we go up 1, 2, 3, 4. And then we're going to go down negative 2 and to the right 3. So down 1, 2, 1, 2, 3. So there's my next point, and I can actually graph that line. And there it is. So this is how you would graph a line after you've solved this. Now, we learned something before, that we could have just taken this equation and solved it for the x and y intercept. So if I was going to find the x-intercept, that would be y equal to 0. So that would be 2x plus 3 times 0 equal to 12. So 2x equal to 12, x equal to 6. So 0, 6. 6, 0 is my x-intercept. And then I could do the same thing for the y-intercept, right? Make x 0. And so that would be 2 times 0 plus 3y equal to 12. And so that's 3y equal to 12. And so y is 4, so 0, 4. So you can see the 0, 4 is existing here. And this would always go out to about 6 anyways. 4, 5, 6. So yeah, these two x and y intercepts coincide to how we would find the slope-intercept form. So that's a really interesting way to do that. Now take a look at another problem, which is a real problem situation, and we'll look at the equation. But this is where we're leading to, is modeling cell phone costs. So suppose the international calls with a cell phone cost $5 for initial connection, and then it's 50 cents per minute. So if someone talks for 23 minutes, what's the charge? Write the slope-intercept form that gives the cost of talking for X minutes. So if we know it's going to cost us initially 5, it doesn't cost us any more after that. It's an initial cost of $5, and then we have 50 cents per minute. So this is our y-intercept, the $5, and the 50 cents per minute is the slope. So if we go back to the screen, my slope-intercept form, I know that this is 5 and then this is 50 cents times x, which gives me the y. So this gives me my equation right away. And then I can answer their first part question, which was, what would it be after what would be the cost after 23 minutes? So then I would put 23 minutes in. So 0.5 times 23 plus 5. And so now I can do the 50 cents on my calculator, multiply by 23, and then add the $5. And so it comes to $16.50 for the month. This is how much it costs for that month. And so that's what you see when you go to the next, you see right here, $16.50. Okay? And then the same thing, what is the charge if it's $8.50? How much did the person talk? Okay, so we can do that as well. So if it cost them $8.50 for the month, that would be my total. And then I don't know how many minutes, so that's my X plus the $5. So I'm going to minus the $5 first, and I get $3.50 equal to 0.5 times X. Now I'm going to divide by the 0.5. So we take $3.50 and divide it by 0.5, and we get 7 as our X. And so that must be 7 minutes that the person only talked for that month, which is unbelievable because most people talk way more than that. And so anyways, this is how we are going to use our equation in the real situation. Also take a look before I close. Right here is this really nice try it globe. So if you do this one, you can actually try this same kind of problem with different numbers, so you can get the idea that you're understanding it correctly. So this is another neat tool to try.